All right, today we're going to talk about caffeine. And there are two different ways that our body can metabolize things that we put into our bodies. So sometimes it is metabolized by the kidneys, sometimes it is metabolized by the liver. So caffeine is primarily metabolized by the kidneys, and it has the same proportion of 13% every single hour. So that 13% is going to stay constant, and it's a pretty accurate value no matter if you're male or female or what weight you are. It's still about 13% every hour. So what we're going to do is look at an example where a person starts the day by quickly downing 2 shots of espresso, each containing 75 milligrams of caffeine. So the question is, how much caffeine will there be at time 0? And we're going to assume that the caffeine immediately and quickly enters their system. Okay, so we are taking 2 shots, each of them worth 75 milligrams. So that gives us a total of 150 milligrams. So that's going to represent our 0. So at time 0, we will have 150 milligrams of caffeine in our system. Okay, next what we want to do is see how much caffeine is in a person's body 1 hour later, 2 hours later, and 3 hours later. So we'll start with 1 hour. Okay, and so one way to solve this problem is we have 150 milligrams currently in our system. We are metabolizing 13% of that amount every hour. So we're going to take 150 multiplied by 0.13, which is the 13%, and that gives us 19.5. So this number tells us how much caffeine is metabolized. Okay, next what we want to do, notice that our output is the amount of caffeine in the body. So this right here is just telling us how much has left the body. So to figure out how much is remaining, we're going to take 150, which is what we started with, and subtract how much actually was metabolized. So we're going to subtract 1950, and that gives us 130.5 milligrams. Okay, so 0, we said earlier, was 150 milligrams. After 1 hour, we have 130.5 milligrams. And so that is how you determine how much caffeine is in the system after 1 hour. Okay, let's go ahead and go to the second hour. Okay, and so when we're doing the second hour, remember, we now only have 130.5 milligrams in our system. So we're going to start with that number, 130.5 milligrams. This amount will still have that same rate of metabolizing, so 13% or 0.13. And when we multiply those two numbers out, we get 16.97. Okay, so again, this is how much caffeine is metabolized. And so to figure out how much is in our system, we're going to take 130.5 minus the 16.97, and that gives us 113.53. Okay, and that 113.53 represents the amount of caffeine in the body after 2 hours. So we can now fill that in on our table. Okay, and then we're going to go ahead and do it one more time. That same idea, we're going to use the 113.53. It's still that same rate of 13%. So multiply that out, and we get 14.76. And then we subtract that from the 113.53. And we get 98.77. So that means after 3 hours, there's almost 99 milligrams of caffeine in the system. Okay, next what I want to do is talk about a different way of solving those same 3 parts. So most students will solve it just like I showed up above, but I want you to pause the video and see if you can find a faster way to get those same answers. So I'm going to have you pause, and then we'll come back and talk. Okay, so a faster way of thinking about it is that we are losing 13%, but that means that 87% is remaining. So let's write that down. So 13% lost or metabolized, leaving 87% of caffeine remaining. And that really comes from 100% minus the 13%, which gives us 87%. So since this particular table is asking for the amount of caffeine that's in the body, we want to think about using that 87% that is remaining. So I'm going to clean this sheet off. And then here's the math that would allow us to do each of those three parts just a little bit faster. So after 1 hour, we were initially starting with 150 milligrams. We are keeping 87% of the caffeine in our bodies. So if you take 150 times 0.87, that will give us the 130.5 milligrams. So all this does is it takes these two steps that we saw earlier, so step 1, step 2, and turns it into like a one-step problem. And then we can do the second hour the same exact way. We had 130.5 milligrams in our system. We're going to keep 87% of that. And when we multiply that out, we get 113.53 milligrams. And then same thing with the last hour. So hour 3, we keep what was remaining. So 113.53 at the start of hour 3. It's going to metabolize and then keep 87% of it, leaving us with 98.77 milligrams. Okay, so either method works. The second way is just a little bit faster. But also, the main reason why I wanted to talk about this second method is this 0.87 becomes really important in our equation because this is going to be our factor. It is telling us how much is remaining, and so that represents the factor, which is the B spot in our equation. So let's see what that looks like. Okay, so I have our table here. You'll notice that I eliminated a couple of the rows, but then we jumped some time and went down to hour 12. So that's going to help us look at part D. So I want you in just a moment to pause the video and reflect on how you computed your answer to the previous part on part C and help you develop a simple expression so we can determine how many milligrams of caffeine are in our system after 12 hours. So go ahead and pause the video and see if you can come up with that equation on your own. Okay, so hopefully you were able to think about our general exponential function, which looks like this: y equals ab raised to the t power. We are solving for the amount of caffeine in our system. The initial value was 150, so remember, a represents 150. I talked about our b represents 0.87 because we are retaining 87% of our caffeine. And so then our time frame for this particular problem is 12, because we are now looking at 12 hours later. And so we can go ahead and plug that into our calculator, and we should get 28.2 milligrams. Okay, so when we have time frames that are much larger than like the first, second, or even third hour, it becomes very, very tedious to do hour 4, hour 5, hour 6 in order to get all the way down to hour 12. So that exponential function that we've been talking about will help us solve this problem much faster. So we just need a time frame of 12 as long as we know our initial value and our factor. All right, for the next part, it says, suppose someone quickly consumes an energy drink containing 300 milligrams of caffeine. Assume the caffeine is absorbed into the body immediately. So I want you to think about what can we do to change the equation we just talked about to accommodate this new situation with 30 milligrams. So go ahead and pause the video to think. All right, and you should have realized that that initial value was 150 on the previous problem. It is now 300. So the only thing that we are changing is the initial value, so that's that A spot. Let me write that equation real quick. So this initial value is the only thing that changed. Our factor stayed the same, and then our T is still going to represent time. Okay, so what I want us to do now is go ahead and pull up the Excel spreadsheet, and we're going to create a table with this new equation right here. All right, just like we did on the previous spreadsheet, we're going to label our inputs and outputs. So our input is still time, T, and then our output is now going to be the amount of caffeine in our system measured in milligrams. Okay, and we can again adjust the size of the cells. And wrap the text. And a little shortcut, if you double click that little line, it'll auto adjust to the size that you actually need. So if you need that little tip, you can use that. All right, so we're going to start with our formulas, put in 0, enter. The next line we're going to do equals the previous cell plus 1, and then hit enter. And then just like before, we're going to scroll that formula down. So move your cursor to that bottom right corner, and then drag it down. All right, and then now we're going to plug in the function for the amount of caffeine. So we're going to use the equation you guys just created. So equals, our initial value is 300. And again, we're retaining 87% of the caffeine. So even though it says 13% is how it's metabolized, we're retaining 87%. And then caret, so close the parenthesis off, caret, and then again we want the input of time to be represented by this cell in the very first column. So I'm going to click on A2. You see that shows up in the equation, and then hit enter. Oh, I did that same mistake as I did in the previous video. We need a multiplication sign in between the 300 and the parenthesis. Okay, and it should have auto fixed it for us, and you can see that here. Okay, so now we're going to take that formula and scroll it down. And this gives us the amount of caffeine when we are starting with 300 milligrams. Okay, so what we can do is graph this so you can see that our graph actually looks very similar to how our body metabolizes Tylenol. So we're going to go to Insert, go to Graph, and again choose that same option. And again, because our B value is less than 1, it's 0.87. So less than 1 tells us that it is a decay. So our graph is going to go in a downward direction. And we have all of these different data points. So this point right here, for example, is 10,74, which means that after 10 hours, there's 74 milligrams of caffeine in our system. Okay, so on part D, it says, what is the end behavior of the function you have graphed? So the end behavior is that it is getting closer and closer to 0. So as time goes on, right, so we read our graph left to right, as time goes on, the amount of caffeine in our system is decreasing, and it is getting closer and closer to 0. But as you can see, it takes a very long time for that caffeine to be eliminated in our bodies. All right, part E is asking for how much caffeine will be in the person's system after 4 hours. So we can go over to our table, and we can see that right here. So an input of 4 gives us an output of 171.87 if we round that. Okay, so that means after 4 hours, there's 171.87 milligrams in our system. The next one, it says how much caffeine will be in the person's body in 30 minutes. Well, as you can see, this table does not have 30 minutes. But one of the things you can do, and you can actually do this anywhere, but I'm going to show it on the bottom. I'm going to take this formula in the amount column and scroll it down 1. You'll see that it shows 300 milligrams, and that's because it's trying to use A26, and it's giving a time of nothing. So it just went back to the initial value. Well, this allows us to put in any time frame. So if we wanted 30 minutes, that is a half of an hour. So we could type in 0.5, hit enter, and then it will use this time frame to represent the amount of caffeine in the system. So that means after a half an hour, there's 279.8 milligrams of caffeine in your system. And then you can use this as a spot to change any value, right? We could do let me erase that. So we could do 4.5 if you wanted 4.5 hours later, right? We can plug in whatever value we want. All right, for part G, it says how much caffeine is needed in the system for the body to have a reaction. I want you to pause the video and do some searching, whether you use ChatGPT or Gemini or Google, whatever you want to do. I want you to search and see how caffeine affects our system. So you probably found lots of very interesting things that I'll have you answer in a question on Canvas. But many of you probably found that as little as 20 milligrams of caffeine in your system can start to affect you. So if we look at question H, it says, if you need your body to be at that level or lower to fall asleep, so the 20 milligrams or lower to fall asleep, how many hours until before bedtime can you drink an energy drink with 300 milligrams? So if we look at this table right here, we're going to find where the amount of caffeine is 20. So remember, our second column represents the amount of caffeine. Here's our 300 milligrams. This is after 1 hour, 2 hours, etc. So we're going to go all the way down. And even after 18 hours, there's 24 milligrams. 19 hours, there's 21. And it takes almost 20 hours before you are lower than 20 milligrams in your system. Okay, so that means that if you wake up at 8 a.m. and start your day with a 300 milligram of some kind of energy drink, and you have 300 milligrams in your system, it's going to take almost 20 hours for that to be completely out of your system. So if you drank it at 8 a.m., that means it'll be 4 a.m. the next day before that amount of caffeine is down to 20 milligrams. All right, so all of the problems that we've been talking about so far is that we have one time where we consume the caffeine, and then that is it for the day. But the reality is that people consume caffeine multiple times throughout the day. Maybe it's having a cup of coffee when they wake up and then having coffee later. Or maybe you start your day with a Red Bull and then you might have another Red Bull, or maybe you have some chocolate, which also has caffeine in it. And so people's consumption of caffeine changes throughout the day. So you consume it, you metabolize a little bit, you consume a little bit more, metabolize that, and that creates a very different type of function. And so that's what we're going to explore here by just looking at some data. So go ahead and pause the video and read that top paragraph there. Okay, so when we initially wake up, we're going to think about drinking 1 cup of coffee. And let's just say it's a regular cup of coffee that only has 100 milligrams. Okay, so we can put in 100 there. The way I broke this table up is that these two rows go together. So at the end of hour 1, we're going to see how much caffeine is in our system, and then we're going to consume more caffeine and see what that looks like. And then you'll see the next 2 rows are for hour 2, and then hour 3. So we always have this idea of before you consume more caffeine and then after you consume that caffeine. Okay, so at the end of hour 1, we're going to have that 100 milligrams that we started with, and it's going to be metabolized. So remember, we're metabolizing it at 13%, leaving 87% remaining. And that is just for 1 hour. So we're going to put a little time frame of 1. And when we multiply that out, we get 87 milligrams. So that means we have 87 milligrams of caffeine in our system. We are now going to consume another cup of coffee, which is going to increase our caffeine by 100 milligrams. So we have a remaining amount of 87 milligrams plus the 100 that we consumed, giving us 187 milligrams. Okay, so now for hour 2, we're going to again consume another cup of coffee, and so we're going to determine how much caffeine is in our system at the end of that hour, and then how much is in our system right after we drink yet another cup. Okay, so we've got 187 milligrams to start with, because that's how much we had at the end of drinking another cup of coffee. It's going to be metabolized for 1 hour, so we're going to multiply it by 0.87. It was metabolized from that previous value for only 1 hour, so that's why we're putting a 1 up here. And when we multiply that out, we get 162.7. Okay, we're now going to drink another cup of coffee. So we're going to take that 162.7, and now we are adding 100 milligrams of caffeine into our system, giving us 262.7 milligrams right after we take that second drink. I guess that would be our third drink, because here's one, another drink, and this is now our third drink. Okay, and then we're going to continue that process for hour 3. We're going to see how much caffeine is in our system, and then take drink one more cup of coffee. So 262.7 multiplied by 0.87. Again, we're using the previous value, so we're only metabolizing it for 1 hour. So again, we're putting a power of 1, and we get 228.7 milligrams. Okay, and then we're going to drink 1 more cup of coffee. So 228.7 plus the 100 equals 328.7 milligrams. Okay, and then you can see here that I have one last row, so we have 4 hours later, so we're going to let this drink that we just consumed be in our system, and we're going to see where it's at after 1 hour in our system. So we're going to do 328.7, multiply that by 0.87, and we get 285.97 milligrams. Okay, so what I want you to do is go ahead and plot those points. We're going to let our input be time. And so we're just going to use those 4 hours. And then the amount of caffeine in our system, so let's label that. Okay, and the highest we ever had was 328, so I'm going to go up to 400. Okay, so I'm going to go ahead and have you guys pause the video and plot those points. All right, and this is roughly what your graph should look like. So we started with our 100 milligrams. It metabolized for a little bit, bringing it down to 87 milligrams. We added another 100 milligrams with the second drink, and then it went down. And so it kind of creates this kind of pattern every time we are consuming caffeine. Okay, so there are 2 things that I want to talk about. So one is there's a nice little app that we have created that allows you to play around with this kind of idea of adding drinks throughout the day. So I'm going to include that on Canvas, so I want you to play around with that app and just see how much caffeine is in your system with either coffee or with an energy drink. The second thing I want you to do is keep track of your caffeine throughout the day. So on your worksheet, you can see that there is an example there. So it is consuming different amounts of caffeine throughout the day. So for example, let's say you wake up and you consume 50 milligrams of an energy drink. You now have 50 milligrams in your system. Let's say a few hours later, you drink some diet soda, and you want to figure out how much caffeine is in your system and then also how much has been metabolized. So this right here, this work represents 2 of those rows that we did on the previous example. So before you consume the diet soda, you want to think about how much of that energy drink that you had at 7 a.m., how much is still in your system, and then you're going to add the diet soda. And then this lets you know how much you have at the end of consuming that drink. And then you're going to repeat that anytime you consume something. So let's say at 2 p.m. you consume some chocolate. It has been 3 hours since that consumption. So your equation is going to be the previous amount of caffeine. Here's how much it is remaining in your system, so 0.87. And then it is 3 hours later. So that's why we raised it to the power of 3. And then this lets us know how many milligrams of caffeine are still in our system. So this is right before you consume the chocolate, and then you take that same value and now add the 24 milligrams that came from the chocolate, so that's this number right here. And it turns out afterwards you then have 102 milligrams of caffeine in your system. And then I have one more example that, let's say at 7 p.m. you now drank another diet soda, and it was 5 hours later. So again, you can see here that we're using that previous amount of caffeine in your system, the same amount remaining of 87%. It is 5 hours later, so then this tells you how much caffeine is in your system before consuming it. And then we take that same value, consume the diet soda, and then this is where you end your day with. And then you will see on this page it says there's an extension question of if your body needs to be at 50 milligrams or lower to fall asleep, how many hours until the body has metabolized enough caffeine to fall asleep? So notice here that we are ending in this example, we are ending the day with 95.9 milligrams. So what we're going to do is go over to our Excel spreadsheet. Okay, so we are using the same Excel spreadsheet that we had just used when we had the 300 milligram of caffeine example. The only thing we need to change is that initial value. So we're going to come up here, instead of having 300, I'm going to use that ending value of 95.9. Everything else is going to stay the same. We still want that rate of keeping 87% of the caffeine in our system, and then we're going to start from the time frame of 0 since we consumed that last amount of caffeine. So hit enter. Don't forget to scroll down your formula because we have a new initial value. Okay, and on this particular example, we want to be less than 50 milligrams. So here after 4 hours, we have 54 milligrams. So it's sometime between 4 and 5 hours after you consume the last bit of caffeine before you can fall asleep. So in this case, the table shows us that we consumed our diet soda at 7 p.m. So 4 to 5 hours later would be somewhere between 11 p.m. and 12 a.m. or midnight before you are able to start falling asleep. Okay, so what I want you to do as part of your homework, and you will turn in this sheet on Canvas, is on the next page, you will see that there is a blank table, and it allows you to keep track of your caffeine for one day. So keep track of what time you consume the item, what actually is consumed, and write down the amount of caffeine, how many hours it's been since you consumed the previous amount of caffeine, just like that table showed, and then determine how much caffeine is in your system. All right, that is the end of this particular lesson. So make sure you go onto Canvas and complete those tasks.